anybody who is a parent or who will be a parent. So here is a headache to look at. This is, I'm going to pull this down because we don't need it right now. This is 100 randomly sampled 2-year-old white American males. And their weights in pounds.
Sweet.
Find Max. He's in there. I made sure to put him in the sample. Actually, I randomly sampled 99 and I shoved Max in there too. Scott!
Just out of curiosity, if we averaged all these numbers out, would that be the 50th percentile?
That's a good question.
Then we go from
If
there.
we average those numbers out, would that be the 50th percentile? What an infuriating answer.
Yes.
Sometimes.
Sometimes.
I know! Because it's not yes or no. It sometimes is and it sometimes isn't. This is good. This ties back to Michelle's consternation from earlier. Scott, that's sometimes. You know why. Good idea.
Fair.
No.
Fair, yeah.
You know why. You guys know why. You don't know why you know why right now. You do know the answer to why that is sometimes. You right at this moment, you don't realize it. Faith?
Is that because of the extreme outliners still?
That's the reason. Hold tight, because this is a nightmare to look at, yes?
Yeah.
So, how about that?
So clean.
That's the same, so clean that I just heard? I love that, Scott. Yes, so clean. This is why raw data is gorgeous. But that is way, way easier to look at. So take a look at this. Same data. Here's 20-pound kids in that sample. Now, you can find them in here if you needed to. They're in there. It's just a matter of finding them. It's a bit of a pain. So here they are. Looks like there's 3 of them. And then there's a 21-pounder. 2 22s, 2 23s, 4 24, and so forth, and so on, and so forth, and so on.
424s.
Good. And then somewhere in there we got 16, 30-pound kids. Okay, so Faith, you mentioned something.
Yes.
My sometimes was based on the fact that we might have extreme outliers.
Like that 150 percentile.
We'll come back to that. We got to talk about that too. But even in this data set, where there wouldn't be any 150th percentiles, I don't think. It depends on how you define that. How would you describe this data? If you had to pick a word, would you? A couple votes for skewed? A kind of bell.
Bell shape.
Okay, there is a bell. I mean, there's a bell here, yeah?
Yeah.
But here's the way, this is my judgment call, and I'm not going to say you're right or wrong. We have tools for measuring skew. You can put that whole block of numbers into Excel, and there's a command called skew. Equals, skew, parentheses, here's your numbers, boom, it spits out a number. You can take it to a table and compare it. But here's how I judge skew. Any skewed curve that's kind of looking like a bell shape, it means it's missing a tail. If you were to continue this, where the tail should be, I think you have to cut too much of the tail off to make that curve. Now, what is too much? Right? What is too much? That's why I'm not calling shots. I call that skewed. If you call it bell curve, that's totally fine. But I call this skew. And eventually, some of us are going to come to a point where we hit a curve where we know it's skewed. It's not bell-shaped anymore. And I want to develop tools to help us deal with that. So that's why I use this. Because when I saw this, I'm like, that's pretty skewed. In my opinion. In my opinion. So if you think it's bell-shaped enough, just bear with me as we kind of get through this language. Scott.
Well, so in relationship to the weight,
Yes.
could these just be considered from 20 to 33 the ideal range for healthy baby boy?
I would imagine they could be.
Versus
Or
like
normal baby boys.
Right.
No,
Versus
no
like
disrespect.
getting rid of the tails, because there's also a tail that's going to be at the 10, 55.
But here's a question I have back for you. And again, this was a sample of 100. That doesn't mean we can't have 19 and 18 and 17 pounders. But the thing is, how prevalent are those in the 2-year-old population? I don't have an answer to that. I don't have an answer to that. But that's why you'd have to put a margin of error on whatever result you got this from. So, and your question, Scott's question about setting up ranges for ideals, it's such a loaded, FYI, if you check my BMI, I am this close to being overweight.
Yeah.
A lot of this.
This close to being overweight. Literally a 1/10 of whatever unit they use is.
It's not an accurate system too,
And how come?
because it's not calculating the mass of your body. It's got, you know.
It's so funny because they call it the body mass index, but they ignore the actual density of your body.
Exactly.
Right.
Exactly.
It's based on your height and your weight and a range that you're supposed to be between. But it negates factors like body surface area, how much skin,
How much skin, how much fat,
how much fat,
how much mass,
how much mass, how much density your body. It ignores all that. And that's why I always get nervous with setting up ranges like that. I'd much rather I like to let people come to conclusions about the data from the data themselves, rather than forcing some scale. We've had this discussion before, I think. Autism rates are on the rise. It's because they've reclassified autism. They changed the definition of what autism is, and it now includes more conditions. So of course, by definition, if you now call a pie or a pizza a pie, there are now more pie is on the rise because now pizza is pie. I mean, that's ridiculous, but that's kind of what we're getting at. Corey, go. Your question. Go ahead.
Oh, never mind.
Are you sure?
Yeah, it's not relevant at all.
Are you sure?
Yeah.
Okay, think about it. If it is, let's bring it up, okay? Okay, so anyway, I got some questions. Matt, find Max.
Using the immediate, so 20.
29,
39.
29, 30,
28.
28. I love it. So we're getting some pretty wide ranges there. I mean, you're within 2 pounds of each other. But I want to establish something here. If you would,
Oh, we still don't know it.
hold tight. I know. Hold tight. If you would, friends, if you would. We do know what he came back at from his doctor's report. He was in the 80th percentile, right? Okay, so here we go. Take a look at this graph and tell me how many 2-year-olds weigh strictly less than 26 pounds. Strictly less. Count that up. Use the graph and count it up.
20.
Strictly less. I mean, I'm getting the answer.